Okay, so good day everyone. So we are now in our part 4, no? So part 4 na ta sa static lateral force procedure. So this will be the last part no for the static lateral force na procedure. So dali na to mga solving guys. So dali na to magamit to mga parameters na inyohang natun-an no from the previous lectures. Okay? So lateral force procedure. So there are three alternate methods of determining the lateral forces in the UBC 97. So the selection of the appropriate lateral force procedure primarily depends on the type of structure. So either regular or irregular, number of stories, then sa height po guys, and among other factors. So muna siya mga basis nimo kung unsay mo ang gamiton na procedure, no? So there are procedures. So naito ka procedure guys na gihatag si UBC. First is the simplified static, then second is the static or equivalent lateral force procedure, and the third one is the dynamic lateral force procedure. So in this case no sa ato ang klase guys, so we will only discuss static equivalent, no, static or equivalent lateral force procedure. Okay, so dynamic is quite complicated, no? Naala siya mga procedures pod na iyaha. The same with simplified. Though even if simplified ni siya, so napon siya difference with regards to the equivalent lateral force procedure. Okay, so when the UBC permits a static analysis, no? So kanusa daw pwede gamiton ng static or kato equivalent lateral force procedure. So the UBC 97 permits two methods to be used in determining the seismic loading, so static and dynamic na guys. So the UBC 97 is very specific about when the static method can be used. So in general, any structure may be designed using the dynamic method at the option of the structural engineer. And some structures must use the dynamic methods. Okay, so wala siya guys. Ang dynamic, indot yun siya. So, mo yung ginagamit karon normally get sa mga high-rise building, no? Kanang dynamic analysis. Because dynamic method is murag suitable siya sa katong gusto na ginatawag na PBD guys. PBD. Okay, so PBD meaning this is the performance-based design. Okay, so performance-based design. Okay. So mo na ang uso karon guys, labi na sa high-rise building, no? And dali pod sa Pilipinas, bago-bago pa ni siya na-introduce, but sa America guys is 20 years ago ginagamit na gina siya, no? Kay mura gina-predict na jud kung sa behavior sa structure labi na kung naay earthquake. So the static method may be used for buildings with the following characteristics. So structures in seismic zone 1 and seismic zone 2 with standard occupancy categories 4 and 5. So whether they are regular or irregular. But sa ato ang requirement guys, since laman tayo lain choice, no, kay wala man ako na-discuss ang dynamic analysis, then even if zone 4 ta, so i-allowed lang ta mo gamiton tong kuan gyapon. Allowed gyapon ta mo gamiton ng static method. Okay? So and also in practice guys, naman ka pa nagagamit gyapon og static method, no, masking tag 10 story na, no, 10 story ang gani 10 story ang structure. So applicable man gyapon siya guys actually, na. So depende gyapon sa structural engineer. Though ang giingon gyud sa UBC guys, dapat ang mogamit lang is seismic zone 1 and 2, no, kay dili man gud sila mga high risk areas for seismic. Okay, so much for that. So second, no, second characteristic is dapat regular structure siya under 73 meter in height. So using one of the lateral force resisting system listed in table na katong sa NCP na kung gihatag katong mga SMRF and all of that. Except regular structure located in soil profile SF, no, kay mura kanid subject to evaluation mga ganing soil profile ani sa SF, which have natural periods greater than 0.7. Okay, so muna siya ang second parameter. So third parameter, so irregular structures less than or equal to 5 stories or 20 meters in height can also use, no, pwede pa ang lateral force procedure. So for irregular structure within this height. Okay, so 5-story lang taman and within this height. So fourth is structures with flexible upper portion. Example, towers supported on rigid lower portion if three conditions are met. So both portions when considered individually are regular. The average story stiffness of the lower portion is at least 10 times the average story stiffness of the upper portion. And third one, the period of the entire structure is more than 1.1 times the period of the upper portion considered as a separate structure fixed at the base. So, mao na yung gusto guys. So, kailangan gahi gitong kwan, upper portion. Samot na kung kanang na yung mga towers, no? No, kay hilig biya ng uban kay gina-maximize it biya no ang upper portion for towers. So, kailangan lang na regular good na. Then, stiffness, bantayan. Then, ang period pa. Okay. So, all structures not meeting these requirements, including regular buildings, must design using dynamic method. Okay. So, pag once na naisa dali na dili ma-meet, wala. No choice ka. So, dynamic method ta. Pero again, as of with regards to our requirement, so allow ta mo igamit ang static method na for your 10-story building. So even if seismic zone 4 na, so pwede ka pa na siya. Okay, so now, so static lateral force procedure. So the static force procedure is also referred to as the equivalent static lateral force procedure. So the structures considered for this procedure are mainly regular structures. So that's why katong sa inyong plano, I encourage you to make it regular, no? Make it simple na para dili ta magka-problema na sa ato ang analysis. Then UBC section 1630.2 provides the provision for determining base shear by the static lateral force procedure. So the total design base shear in given direction should be determined in accordance with equation 6.22. Okay, so muna ni guys, so muna ni atong task karon na kuha na ginato ang base shear no sa ato ang structure. So I think this is the formula that I gave last time, no. I think familiar na ni siya, no. Muna itong CS, no. So this is the lateral or base shear coefficient, no. From the general formula, that base shear should be equal to CS times W. And with our part 3, so i-discuss na natin ng CS kung saan siya, diba? So, kana. So, think familiar na yung CVI over RT and times W. So, muna ito murag basic na formula for base shear. Then, based on the design response spectra, identified in section 6-30, so the CVI over RT portion of the spectrum is velocity controlled and it is representative of longer period structure. So I think familiar mo itong drawing last time, di ba? No, itong hinana guys. Kana. Okay, so muna itong ginatawag na response spectrum. Napasabot katong nadari na part is mo nitong velocity control, di ba? Motong velocity control. So darito na bilong si CB, no? I think dito lapita. Si CVI over RT. So the equation is cap from the acceleration control portion of the spectrum. So which controls shorter period structures. So the code sets this limit by the way of this, na. So I think familiar na siya. So I think this is the CS, di ba? So CS maximum. Okay? CS maximum. Katotong dali sa flat portion. Okay, last time sa spectra. So mo to first formula to guys. Again, this is the first formula for base shear. So this is the second formula for base shear. Then third one, okay. So in equation 6.23, so which is this equation here, kani. So in all seismic zones for short period structure, CA represents the effective peak acceleration at grade with a maximum natural period of 1 second. So for long period structures, based on the design base shear requirement of the UBC 97 in Formula 30-6, the minimum total base shear in all seismic zones can be determined using this equation. Okay, so this is the base shear minimum. Okay, so equation 3. So muna ikatulo na formula for base shear. And also do not forget katong base shear minimum sa seismic zone 4 kani. So in addition, for seismic zone 4 only, so the UBC 97 requires that the minimum total design base shear be more controlled to account for near source factor no katong NV no namo ko NV involved diri sa formula. Okay, so this will be our minimum base shear at zone 4. Okay kana. So ito yung pamilya na last time kaning CS. This will be our equation 4. Okay. So kana siya guys, moto. So moto upat ka formula no na imong kailangan for for determining base shear. Ano? Okay, so now let us proceed to our example no for static lateral force procedure. So a 30.48 meter 10-story office. So I think haom na ni siya sa inyo ano na example. So 10-story office building has a total weight of 66,723 kilonewton. So this will be your W. Okay. So unsay pasabot ani guys, asa nagikuha? So tanan weight na guys from the mid height of the first floor. So that is from the mid height of the first floor padulong dito sa taas. Okay, so padulong dira. Kana tanan gipangkuha na niyang weight. So mao na ang weight, total weight guys. So 66,723 kilonewton. Okay. So the building is in seismic zone 4, then 5 kilometers siya guys from the seismic source with a high rate of seismic activity. It is designed with a special moment existing steel frame. So SMRF guys na steel. Then ang soil type is SB. Then now we are tasked to use the static lateral force procedure or equivalent lateral force procedure to calculate the total base shear. Okay. Okay, so this will be our solution. So the first is the total design base shear kani no katong first formula guys. Okay. So given na ning W, so do not worry about W. So ang mukha na lang mga problema guys is si CV, si I, then si R, and si T. Okay. Though last time na-discuss na natin na. So di na kayo na siya na naka-problema. Okay, so first na yung i-determine dali guys is the T or the period. Okay. So we will be using method A. No? So method A to determine the period. So CT then times HN raised to 3/4. So familiar. Okay, so period na ta. So given, no? So since our structure is special moment resisting frame, so mo ni last time ato nakuha. So 0.0853 no katong sa table na ta guys, no? Mo sa CT, then this is a total height. So 30.448 meters. So substitute the values from the period. So kani. So we have this T, no? We have this period guys, 1.11 seconds. Okay, so from the NCP table, the special moment resisting frame R is 8.5. So I think sa UBC guys, no? I think sa UBC ang value sa UBC ani, di ba? Last time kato kung i-compare. So 8.5 sa UBC, no? But ang gusto man ko na to gamitan guys is the NECP. So sa NECP is I think 8 na rin siya. Okay? So sa NECP 8 na rin. Okay? But ang gamiton sa proposal is NECP. Okay? NECP ta. So from table 6.5, so since this is an office building, so I think katong kuan na siya guys. Katong normal lang siguro na structure. So motong ang I is 1. Then total weight na natana, total weight given. Then SB na kuan given. Then seismic zone 4. So 0.4. So therefore gikan dito sa table guys, mo na yung nakuha na CA and CB. Okay? So kana siya. So kamo na lang mangita sa table ana, okay? So sa table na siya gikan, pero kailangan niyang NA ug NV. So again from the table no sa NA and NV, so nakita na to dito guys na ang site is 5 kilometers lang no from the known seismic source. So from the table ang nakuha niya na NA and NV is 1.2 and 1.6 no, due to this distance. Okay, and katupong seismic source type no, ang seismic source type niya is A no, kay since kay duol biya kay siya 5 kilometers lang siya from the near source, so gina-expect niya na high rate ang seismic activity or katong 7 magnitude 7 and above. Okay, so type A then 5 kilometers, so 1.2 1.6 for NA and NV respectively. So makuha ng CA guys, so substitute lang NA 1.2 times 0.4, so 0.48 CA. Then for CB 0.4 times 1.6, so CB is 0.64. So gikuha na po na to apil ang CA guys, kaya magamit ata ni siya later sa minimum. Okay, gamit na siya dito. So substitute value for CB, so 0.64, then I substitute 1, then R 8.5, the R value, then the time na 1.1 or 1.11 seconds, then times the weight. So therefore we have this first value for base shear. Okay, so na siya no, from this formula or sa formula 1 na to, sa total design base shear na to. Okay, ana siya ang pinakauna, but still we have to check it no, katuwa siyang i-compare with the minimum and the maximum. Okay, so next is we will get the minimum total design base shear using this formula. So 0.11, then CA, then I, then W. So we have this V min. Okay, so this will be our velocity minimum. Okay, using this formula. Then in addition, for seismic zone 4, the above minimum value of total design base shear is further limited as according to the UBC 97 formula. So kanay guys. So for seismic zone 4, so 0.8, then zone 4, 0.4, NV 1.6, I 1, then R is 8.5, then the weight na given. Okay, so we have this minimum. So B min seismic zone 4 kana. Okay, so 4,019 kilonewton. Okay, so V min seismic zone 4 is greater than the V min na katong isa, 3,524. So therefore, the total design base shear V cannot be less than this value. Okay, so the calculated design base shear V is equal to 4,526 must be used in designing this structure because it is greater than the V minimum seismic zone 4. Okay na. Okay, so muna ta sa minimum, then try to solve the maximum. So based on UBC 97, total design base shear need not exceed the maximum total design base shear. So this is the formula for maximum total design base shear. Okay, so kana siya 2.5, then times CA, substitute, then I1, then R 8.5. Then also the weight. Okay, so B max is 9,419.72. Okay, so therefore, no, so from the 4 V na inyo nakuha na base year kani, then kana, then B minimum, then kana pod B max. Okay, so the calculated design base year B is 4,526. So kani man gina siya ang murag original na design base year nimo guys kana. So 4,526 is not greater than V max. Okay, okay, mas dako pa man siya pasabot ang B nimo is less than B max, so okay na siya. Okay, so okay na siya. Then also ang imong B pod is greater than the B minimum. Okay, B minimum. Okay, so kuan mo gani guys, di ba duha ka V minimum, so dili pasabot na minimum katong gamay na dito, dili na. Okay, so ang pasabot is katong kuan kani katong dako na value. Okay, kani siya. So nag-prevail dali guys is kani 4,019 kilonewton. Dili ni siya kay pag once kung kani mong i-consider na B min tapos mao ni imong original design base shear, so there's a possibility na kani siya mabagsak na siya dara, no, mabagsak ni siya ni na value, no, 4,019. So kani itong gipili na minimum kay para mo pasa siya sa duha, no, kani imong design base shear pasal dara B minimum, then kana po dara mo pasal po na siya dira sa taas. Okay, so since B is greater than V minimum, then okay gapon, tama. Okay, so consequently, so V which is equal to 4,526 kilonewton is the controlling total design base shear. So kung tanan ka unsa gid ang base shear, so mo na ang answer guys, si 4,526 kilonewton. Okay, so mo na siya. Okay, mo na ang answer. So what if guys, what if kung ako nakuha nimo na V is 9,600. Okay, what if kung mo nimo nakuha na base shear, so 9,600, so unsay mo ang prevailing base shear? Okay, so ang prevailing base shear is katong maximum kana si 9,419.72. Mao na yung answer. Nga naman, since ang imuhang design base shear is ning lapas sa maximum, no, so moment to siya, no, kaning lapas siya kaning greater than man siya sa B max, ning greater than siya sa B max, therefore B max imo answer. Okay, so di pwede malapas ani good. Okay, so kana what if guys, what if na po, say what if kung ang V nimo is what if mo ang V is 3,600 kilonewton. Okay, what if kung 3,600 kilonewton siya, so kung ang V nimo is 3,600 kilonewton, then unsay mo ang V, so imo na i-compare na pod sa minimum karon. So dari pasa siya dari, tama, no, pasa siya, no, kay ang kani siya is less than man na siya sa V na katong 36 na ako ang given. Okay, so okay na siya, okay na. Pero dari pag abot dari dari ta nagka problema, no. Okay, ang B minimum nimo mas dako compared with the 36, so that okay, no, so dili siya okay dala. So therefore ang mag-prevail So therefore mag-prevail is 4,019 kilonewton. Si B minimum. Okay? So ana siya guys. Okay? Ana ang analysis. So try to compare no. Kani gid na value dali kani. Mo ni pinakauna i-solve kana. Then try to compare it with the minimum and the maximum values. Okay? So that's all for Bayesian. Okay, so next, how about if ato ang i-distribute no ang katong Bayesian no, the vertical distribution of Bayesian to stories no, each stories na to. So in the absence of justifiable more rigorous approach, the Bayesian B is distributed to the n stories in accordance with equation 6.29, or this is from the UBC formula 30-15. Okay, so n stories were in, so in your case proposal 10 stories na. So the fx forces increase linearly with height above the base as shown in figure 16.15, which will be illustrated here no. Kani siya, kani guys, mali siya si figure 6-15 kana siya. So makita niya dali guys that aside from having those fx no na force dali with respect to base shear, so napan may mabantayan na ngano na ft. Okay, so ft is an additional force no, additional force na siya guys that is applied to the top level. So for example dito sa roof deck no, or sa roof portion, so in addition to the fx force at that level, so natay mga conditions for ft. Now the ft accounts for higher mode effects. So it is 0 for time or period which is less than or equal to 0.7. Okay, so ma-0 na siya guys pag less than 0.7 second, less than or equal. Okay, pero pag mag-greater than siya og 0.7 ang mga period, then ft can be obtained from equation 6.27. Okay, so the story shear Vx is the sum of the top force Ft and the forces Fx above that story. Okay, ito na yung formula dali guys. Okay, so Ft is equal to 0.007 times T times the base shear. Pero take note guys that Ft should be less than or equal 0.25 of the base shear only. No, pag once malapas siya sa 0.25 times B, then the prevailing Ft is 0.25V. Okay, so dapat mauna na siya less than or equal lang gid siya na guys. Pag once say 50% na sa base shear lang Ft, then dili na pwede. Kay mao ra giniyahang upper limit na ginatawag. Then ft is 0, kani na-introduce na kanina. Then we have this formula for ft guys no, ay fx rather. Fx is equal to base shear minus ft, then weight of x no at that floor, then height x no, then vx no, or the total base shear should be equal to the summation of story shear then plus ft. Okay, so do not worry, atuan lang i-discuss later. As figure 6.15 shows no, kani guys, kaning sa building na linear na siya. Okay, so the distribution of fx is linear. Okay, so this distribution depends on the following assumptions. So structures do not meet these requirements must receive a dynamic analysis. So nato yung mga additionals ba guys no, additional requirement kaganina na kaganata mong requirement on when to use static lateral force procedure. So karon another conditionable or requirements in order for us to distribute fx in linear no, in linear form. Okay, pag once magud mag-dynamic na guys, so dili na linear no, so dili na inani Kani. Mo na yung ginapasabot na linear dali guys na from the ground to dito sa taas. So, naka-line na siya. Pag dynamic na siya, dili na siya line. Okay? So, na siya mga other methods. So, first requirement, the building is regular and nearly symmetrical. Okay, so mo nito sa inyong plano. So, fully regular and nearly symmetrical to. Second, the lateral stiffness of each floor are approximately the same. So, I think nataga na mong idea last time on how to make the lateral stiffnesses of each floor halos the same, no? Katong mga sa lesson about regular and irregularities. Then also the lateral stiffness of each floor are uniformly distributed in the plan. Okay? So the weight of each floor is approximately the same and it is uniformly distributed in the plan. Okay, so I think ma-check na ninyo no, for each floor. Then there is a continuous load path between members. Okay? Siya. Then torsional components of drip are small compared to translational components. So with regards to this requirements, so we'll assume guys na small lang yun, no? Assume na to na na-meet na ni na requirements sa inyong plano. Okay? Kaya basi di na takabot sa drift, no? Kay we still have one lesson pa dyan, no? Napaka lesson na i-discuss sa inyo further. Which is kato mga pangutanan niyo about mitigations, about sa kung unsa na ang unsa tong gibuhat to lessen the destruction sa structure when it comes to earthquake. 7. The first deflection mode can be approximately represented as straight line. Okay. So those are the requirements. So now proceed sa example guys. So a 5-story building is constructed with 12 feet or 3.7 meter story heights. So the base shear has been calculated as 0.71 meganewton. So each story floor has a weight of 3.6 meganewton and the roof has a weight of 3.1 meganewton. So the natural period of oscillation or T is equal to 0.5 seconds. So what are the story forces? Okay. So the top force FT0 no kay ang time na to is 0.5 man. So that is less than 0.7. So natay FT. So a table is the easiest way to set up the data for calculating and recording the story shears, no? Kailangan i-table guys para dali lang na pag-solve sa story shear. Okay, so I think familiar ni siya, no? Familiar ni siya na formula kagaya na. Asa na ito ni nakita? Kaya siya. Okay. Katong sa fx. Okay, na formula. Katong da rin. Kani guys. Kani siya. So, ito na ito na mga formula guys. So, now, imuhang ihanay guys, no? From the first to 5th story. Again, ang pasabot na po niya dali sa first story, kaning 1 dali guys is second floor na siya kung dali sa 2A. Okay? Second floor na siya. So again, dito sa ilaha manggod, pag moingon kag kuan first floor ni sa ilaha. Okay, mo na ang first floor sa ilaha. Okay? So sa 2 dali, second floor na na. Okay? So HX, so 3.7. Okay? So, 3.7 each man to, di ba? So, height 3.7, then HX kana na pod. Okay, so murag i-add lang nimo na siya guys. Kanina height guys is from the ground ni siya gikan. Okay, so with respect to the ground. So 3.7 plus 3.7 na pod, then 3.7, 3.7. Okay, so add lang. So mo na to ang HX. Then for WX is mo na tong weight per floor. So, mo na yung weight 3.6, 3.6 ang weight each floor. Pero nag-vary lang to pakabot sa roof, di ba? Kaya sa taas, ning gamay to ang 3.1 as given sa problem. Then, what we will do now is multiply HX times WX. So, multiply niya na. So you will have these results here. Okay. Then hx times wx over submission of hx wx. So ang submission of hx wx is add up all of this, no? Add nyo man tanan, guys. Okay, so ang result na to is kana. So 188.49. Okay? So para makuha ning 0.304, so 56.73 divided by 188.49. So this must be the result. How about for 0.278? So 52.56 divide nimo ani na pod. Okay? So makuha nimo na and so on, no, hantod sa mo kuha nimo anto ni diri sa first floor. So kana. Then after getting this, then apply the formula for fx, no, kato. Kani guys. So apply this formula here. Kana. Okay? So kani mo na nito na sa table. Then ang buhaton na nimo kanin kato siya na formula, i-multiply na nimo ta siya sa v minus ft. Since 0 man ang ft, then sa v na lang nimo siya multiply, na. So 0.304 then times nimo sa 0.71, no? 0.71. Okay. So which is our calculated base year, guys. So 0.71. Okay. So ang makuha dapat is 0.22 for the fifth floor or sa roof. Then sa fourth floor 0.2, then 0.15, then 0.09, then 0.05. Okay, so naay kuan diri, guys. So naay murag sample solution lang for level 5 lang. Okay. So mo ni, guys. So 0.71 minus ft, which is 0. Then this is result, no, 0.034, no, from this value here. Okay. So makuha nimo, guys, is 0.216 meganewton. So mao na siya dali, guys, 0.22. So inandi lang gyapon ng mga solutions, guys, for F4, for F3, for F2, and for F1. Okay? So kana siya. And dapat, guys, take note, dapat ang imuhang kaning tanan fx nimo should be equal to the base shear. Okay? So pag once dili na siya mo equal sa base shear, pasabot mali, no, mali imong solution. Okay? So pasabot man gula ni, guys, katong base shear nimo na 0.71 gi-distribute nimo to each floor. So not necessarily na equally distributed, no? Kay talawon nimo dili man na equally distributed sila. Kaya nagdepende maguna sa weight and sa height pod. Okay, sa imuhang floor. Okay? So basta ang importante is pag add nimo tanan ng fx nimo, equal na siya sa shear. Okay, sa base shear. Okay. So unsay buhaton nimo ato mga nakuha nimo na force sa F5, F3 and padulong sa F1, so imo to distribute diri sa isa. Okay, so taas ang arrow diri kay 0.22 man na, then 0.2, 0.15, 0.09, then 0.05 mega newton. Okay, so inana ang pag-distribute, guys, so linear lang na siya, linear. Okay, so linear. Okay, so kana no, inana lang siya, inana lang ang vertical distribution sa base shear to each story. So F1, so dapat the same with kana pag i-add ta na ni, so dapat base shear 0.71. So what if, guys, kung nay FT? What if kung nay FT asa ibutang dito sa roof? O dara, nay FT. Okay? So nay FT. So pag once nay FT, guys, I think pag once nay FT, so dapat kanimo base shear dere, kanay mo base shear is equal to FT then plus summation of fx. So I think mo na siya dere sa formula. Okay, tara. Okay, mo na siya. So once na ft, guys, no, once na ft sa taas. So ft plus katong add nimo tong tanan forces dere. Okay? So fx. So ana lang guys, no? So as of today, so ang natun-anan ninyo is to get the base year, no? So today, no, kabalo na taon sa pagkuha sa base year, no, the total design base year. Then also the distribution, vertical distribution of base year to stories. Okay? So your assignment is to distribute, okay? From this example, no, sa atong example 1 kaning 10-story office building. So nakakuha naman ka base year, di ba guys? Natay base year ka kanina na kani si 4,526 kilonewton. So ang buhaton ninyo is to make a vertical distribution, no? Kung ano yung vertical distribution na each. Okay? So kung ano yung vertical distribution na siya dala. Ano? Okay, so drawing na ninyo the same with what we have done sa last part, no? What we have done sa last part kani. Okay? So ang problema lang gamay guys is total to yung gihatag dito. Okay, so 'di ba total weight na to yung gihatag. So para makuha ninyo ni mga weight dere, so equally distributed na siya, no? So I think divide 10 nimo, no? Divide 10 nimo para makuha nimo ning weight dere kana, no? Para makuha nimo siya. The same with height. So equally distributed lang gyapon na siya guys, no? Kana siya da, total man guna siya, ang gihatag lang. So total lang gihatag. So ikaw na bala sa ano mo na pag-distribute ang weight each floor. The same with the height. So naman kay 30.48. So ikaw na bahala sa ano mo na pag-distribute dara each floor. Okay?